Hi, algebra students. So over the past couple of weeks, we have now looked at all the different types of laws of exponents. So if you think back to the pages of notes we've already taken, we've learned about multiplying and dividing with like bases. So we've learned the rules that if you multiply exponents with like bases, you add the exponents. And we've learned that if you divide like bases, you just subtract the exponents and decide if it goes on the top or the bottom. And then we looked at what it's like to do that with coefficients in front. And then we learned the power rule. So if you're raising a power to a power, and how that is raising another power to a power, you multiply the exponents. So we did that, and we also did that with coefficients. And then last week we worked on negative exponents, and we looked at if a negative exponent is equal to a positive exponent in the denominator, and same thing if it's in the numerator, you flip it to the denominator. If it's in the denominator, you flip it to the numerator. So negative exponents just flip. And so today what we're going to work on for this week, and our unit test will be very soon, is combining. Let's call it combination of laws of exponents. All right, so combination of laws of exponents means that now that we know all the laws, we're going to be using either two or more. So I like to describe this as sort of like order of operations. So if you remember, if you have a big long string of, addition, subtraction, multiplication, division, exponents, there's a certain order you do them in, right? You always have to deal with parentheses first, and then exponents, and then multiplication, division, and addition, subtraction. And that you learned probably in 6th grade. Maybe 5th grade. And so the same rules are going to sort of apply when we have multiple steps of laws of exponents. We're going to, of course, deal with anything that we can work out inside parentheses first. So if you remember, I'm just going to write the steps here. Anything in parentheses first, then we're going to deal with exponents on the outside, because of course everything has exponents now. And then if we're doing any multiplication and division, and actually there's not any addition. We haven't talked about addition and subtraction yet as far as laws of exponents. We're going to get there, but that would come last. But we're not even going to have to worry about the addition and subtraction today. We just want to make sure that we're doing it in this order. And so we've got 8 examples to go through, because there's lots of different ways that this might look. So I'm going to go ahead and split my page down the middle. And then I'm going to put 4 examples on each side, and we're just going to split the page off after we finish with an example. So without further ado, let's start with example 1, and I'll zoom in a little bit. All right, so example number 1 is going to look like this. So we've got parenthesis 12x squared, parenthesis 6x to the third y, all over 4x to the fourth y squared. All right, and so we're going to look at the steps that we need to take here in order to simplify this. So your instructions will always be to simplify. And of course, if you'll notice, we've got sets of parentheses. We've, of course, got a lot of exponents. But notice we don't have any exponents on the outside of the parentheses, so that's going to help us out some. And we do have multiplication and division at the same time. So we're going to work through this sort of methodically. All right, look inside the first set of parentheses. Is there anything to simplify in here? Well, not really. It's just 12x squared. So there's nothing to do in that set of parentheses. What about over here? Can we simplify anything? 6x to the third y. Nope. A number, a variable, and a different variable. Nothing to simplify there. So parentheses, I've worked out there's nothing to simplify inside my sets of parentheses. Next thing we're going to do is exponents. Well, again, as I said before, there's no exponent. We're going to do an example here in a second where there's an exponent that actually needs to use the power rule. But right now, I mean, x is being squared, sure. X is being cubed. Y is to the first power. There's nothing really to work out as far as exponents go either. The exponents are just hanging out next to their variables. Now, if we had an exponent that we needed to, again, use the power rule for, we'd have to do that next, but we don't have that here. So the next thing we're going to do is just multiply and divide, and that's really all that's going on here. So we have to multiply what's on top first, because we can't divide until we figure out what this top is equal to. So I'm going to say equal to, and so on the top, we're just going to focus on the top right now. Notice I've got 12x squared times 6x to the third y. Now this is a product rule. We're multiplying here. And so what that means is we're going to multiply the numbers, the big numbers. So 12 times 6 is 72. And then we're going to multiply x squared times x to the third. They have the same base. So because they have the same base, what are we going to do to these exponents? We're going to add them. So 2x's, 3x's, that is x to the fifth. And then the y has nothing to multiply by on the top. So we just leave it. All right. And then that is still over 4x to the fourth y squared. Now we're ready to do the division step, right? And again, like I said, there's not really going to be any addition and subtraction here. So we're ready to divide and we're ready to simplify this way. Now we combine on the top, but notice now we also have variables that have like bases here that we're dividing. So we're going to deal with the coefficients first. So 72 divided by 4, you could type that in Desmos. 72 divided by 4 is actually 18. Is it going to go on the top or the bottom? Well, this is like an improper fraction. So it would really simplify to 18 over 1. So 18 is going to go on the top. 72 has more. 18. Now we're going to look at our x's. And so I've got x to the fifth. That's 5 x's on top, 4 on the bottom. You can think about, crossing those out or subtracting the exponent. So 5 minus 4 is 1. So we're left with 1x, and where's it going to go, top or bottom? It's going to end up on the top because we had more up there. So 18x. And then we've got our y's that we're going to simplify. Well, same base, subtract the exponents. There's really a 1 there. And so there's 2 down here, 1 up here. We know our answer is going to end up in the bottom because there's more in the bottom. And 2 minus 1 is just 1. So over y. And that is your final answer. And so notice how much simpler that looks than what we started out with. And notice again, we just sort of used order of operations rules to multiply everything on the top and then divide by simplifying, using our product rule by adding exponents and using our quotient rule by subtracting exponents. Okay? So that is the gist of what we're doing. Let's look at example number 2 where we have an exponent. So let's do 2x to the 2 in parentheses 2xy to the fourth in parentheses, and then negative 2xy to the third, and then in parentheses squared. All right, and so again, we're using order of operations. So parentheses, check your parentheses first, but again, there's nothing to simplify here. We've got a 2, we got an x, got a y. There's nothing to actually combine there. Same thing over here. We got a negative 2, an x, and a y. Nothing to combine over there. So parentheses are done. But we do have this exponent on the outside. Now, there's nothing, these exponents, the y to the fourth, these inside exponents don't have anything else to do. However, we do have to use our power rule to evaluate this. So I'm going to rewrite, I'm just going to say it's equal to parentheses 2xy to the fourth in parentheses. But then I'm going to go ahead and apply the power rule here. Now remember, everything gets raised to the second power inside the set of parentheses. So negative 2 to the second power, that's negative 2 times negative 2, which is 4. Positive 4. Negative times a negative is a positive. X is going to get squared. And y to the third is going to get squared. But remember, when we raise a power to a power, what do we do with our exponents? We multiply them. So 3 times 2 gives me 6. And so that's going to be y to the sixth. Now, there's one thing left to do here. We've applied the exponent, but now we're ready to multiply or divide. And we do have one more multiplication step here. So we're going to use the product rule. Coefficients just act like normal. They're normal big numbers. 2 times 4 is 8. We're going to we're going to multiply our x's like bases. So this is x to the first, if it makes you feel better to put that in there. X to the first, x to the second, that's x to the third power. And then y to the fourth, y to the sixth. We're going to add those just like we did here. And so 4 plus 6 is 10. And so your final answer here, simplified, would be 8x to the third, y to the 10th. And so again, I mean, the rules are not going to change, but the way that the problem is presented might change. And so I just want to show you as many examples as I can. There's no way for me to show every single example of every single type of problem that you might see, but I tried to cover as many areas as I could. So parentheses example 3, parenthesis 7x to the ninth, y to the negative third, in parenthesis 10x to the negative second, y. All right, and so we want to simplify that. Let me zoom this in a little bit so you can see better. Now, notice we have some negative exponents here. And there are going to be times where it's going to be easier to deal with the negatives and go ahead and put them into the denominator. And there are going to be times where it's going to be easier to just go ahead and do the math. And so, again, I'll show you an example of each one where sometimes it might be easier to do one thing or the next. But in this case, because everything is on the same level right now, my gut is telling me to just go ahead and use my rules. And then if I need to flip anything to the bottom, I can. Now, of course, you could go ahead and flip negative exponents to the bottom here. It just depends on if you want to do math with negative numbers or if you want to go ahead and make everything positive. So it's really up to you. And actually, I'll show you both ways. But if we were just going to multiply it, I mean, this is just a multiplication problem, right? So big number is 70. X to the 9th times x to the negative 2nd. Again, we're adding those exponents, right? So notice how the negative almost goes away because 9 plus negative 2 is 7. So we end up with x to the 7th. And then we didn't even have to flip this downstairs. Now I'll show you what would happen if you did flip it. Then y to the negative 3rd and y to the 1st. Right, there's a 1 there. So again, just add them. But that's going to be negative 3 plus 1. That's y to the negative 2nd power. Again, take a second and make sure that you see that all I was still doing was adding the exponents. And now the last step is to just deal with that negative exponent here, right? And so we just flip it to the bottom. So your final answer here would be 70x to the 2nd and then y to the 2nd on the bottom because negative exponents just flip to the bottom. Now, if you wanted to go ahead and flip everything to the bottom first, you would have ended up with something that looks like this. So you would have ended up with 7 x to the 9th, and it would have been over y to the 3rd, right, if you went ahead and took that down. I'm going to leave that in parentheses because we're still multiplying. And then over here, it would have been 10y left on top, but you could have flipped the x squared down to the bottom. And then, of course, you would have had to multiply this. So I'm going to squeeze this in. 70 still on the top. But then on the top, we would have had x to the 9th y over, and on the bottom, we would have had y to the 3rd x squared. And then you would have still had to simplify here, which still would have ended up being 2 in the bottom, right? There's 1 here and 3. So that still would have left us with 2 y's in the bottom and 7 in the top because 9 minus 2. But it almost took more steps to do it this way, to flip it first. So go ahead and do the math with the negative numbers and then flip it in the end when you need to get rid of that. Example 4, x to the. Let's look at another one with some negative exponents. So let's look at something like this. 5x in parentheses to the negative 2nd power. Now again, you could go ahead and flip this because there's two things happening here. There's a power rule because we need to apply this negative 2nd power to everything inside this parenthesis. But there's also a negative, which means it's going to end up in the bottom. And so, again, you could do this sort of two ways. One way would be to think of 5x as one thing, and that it needs to be flipped into the bottom and made positive. So to flip it in the bottom, we could put 1 over 5x and in the denominator, make that to the 2nd power positive. So that's one way of doing it. Now, you'd still have to square everything. So it would be 1 over 5 squared is 25, and x squared is just going to be x squared. So that would be the final answer. Now, of course, you could do the power rule first and sort of with order of operations think about having to raise something to a power first. So I could say, well, this is going to be 5 to the negative 2nd power and x to the negative 2nd power just by using my power rule by applying the exponent to everything. But then that's still going to flip everything in the bottom. So now we end up with 1 over 5 to the positive 2nd, x to the 2nd, and notice how that still ends up being 1 over 25 x squared. So whichever way makes the most sense to you. Again, there are multiple ways of doing some of these, similar to order of operations. You can just get there in multiple ways. So for that line, we sort of had 2 ways of getting there. All right, let's look at, remember I said we had 8. Just because there's lots of different variations. So this is example number 5. And example number 5 is going to look like this. 6y to the negative 5 and then 10y to the negative 9th. Now, at first glance, we may be looking at this and saying, well, stuff just needs to be flipped. And it does. Notice that your numbers don't have exponents, right? These are just numbers. They do not have, this is really 6 to the first power, 10 to the first power, so they don't have negatives. They're not going to flip. So we're going to leave that as 6 and 10. But now the y's are both negative. So this y to the negative ninth is going to go upstairs, y to the positive ninth, and then y to the negative fifth is going to go to the bottom, y to the positive fifth. But notice now we can still simplify this, right? Not only will 6 over 10 simplify, but we have like bases on the top and the bottom, so we need to simplify that. So think about 6/10 as a fraction. 6/10 will simplify, and that becomes 3 over 5. And then we need to simplify our y's by subtracting exponents. And so y to the ninth over 5, 9 minus 5 is 4, and it's going to end up at the top because there are more on the top. So 3y to the fourth all over 5 would be your final answer. All right, example 6. Might look something like this. So what if we have a quotient that needs to be simplified, 4x all to the second power. Notice that, again, there's really two different ways of doing this. But if you're following order of operations, you're going to be thinking, okay, whatever's in the parentheses first is what I am going to simplify first. And so one way of doing this would be to simplify inside of the parentheses. So 2 over 4 is going to simplify. That's 1/2. We don't really need to put the one, well, let's use it as a placeholder. So 1 over 2 as the fraction. But then notice your x's like bases. There's really a 1 on this x. We can simplify that. X to the fifth over x to the first. 5 minus 1 is 4, and it's going to end up on the top. So x to the fourth on the top. Again, notice we didn't really need that 1. We could have just left it x to the fourth. But now this whole thing is still being squared. So I'm going to clean this up a little bit. So we now have x to the fourth, 1x to the fourth, over 2, all being squared. And so now we're going to simplify that. And we're raising a quotient to a power. So remember, the power goes to the top and the bottom. So if I raise x to the fourth to the second, we multiply the exponents. That's x to the eighth. And then 2 is also going to get squared. And so that would be 4. And so the answer on the bottom, or the final answer, would be x to the eighth. Now, you could have squared everything first. You could have applied that exponent. You would have still had to simplify this, but it helps, again, to just follow order of operations. And since this is all in parentheses, simplify first and then raise it to the exponent, rather than having to deal with all the exponent and then having to simplify. All right, so that's example 6. We've got 2 more just to look and finish out what exactly all of these, I don't even want to call it order of operations. It's order of exponents. Oh gosh, sorry I dropped you. I mean, I told you y'all a few videos back that these were going to get way less professional. Sorry about that. Hope you weren't staring at the screen and felt like you got dropped on your head. All right, last 2 examples. Here we go. Let's look at one with where we're raising everything to a negative exponent. So this is going to be very similar to what we did on the last example. Only notice on this one, we're dealing with a lot more negative exponents. And also, if I look inside the parentheses here, there's x, y, and z. There's nothing to simplify inside the parentheses. So I am going to jump straight into applying this outside exponent to everything, erasing everything using the power rule. So x to the negative fourth to the negative second. So we're dealing with negative exponents, but we're still raising a power to a power. So that means power rule. That means multiply. So x, negative 4 times negative 2 is positive 8. Y is going to be raised. There's really a 1 there, right? And 1 times negative 2 is y to the negative second. All over z to the negative 3, raised to the negative second, power rule. Negative 3 times negative 2 is z to the positive 6. So notice how a lot of our negative exponents just went away just by multiplication. We do still have one more negative exponent though, and so the last step will just be to take care of that. So we end up with x to the 8th on the top, but then y to the second, z to the 6th on the bottom, and there's nothing else to simplify there. All right, one last example. And if you can do this example, you can probably do them all. All right, so the biggest and the baddest of them all is example number 8. Here we go. All right, in parentheses, 3x to the 5th, y, parenthesis, 3, in parenthesis, negative x squared, y, all over 3x to the negative 1. If you want to pause the video here and try this on your own, have at it, and then we will go through it. All right, so if you tried it, let's see. All right, so the first thing we're going to look at in parentheses, nothing to simplify here, nothing to simplify here. Ready to move on to exponents. Ready to raise everything here to the third power. So on the top, we get 3 to the third power. That would be 27. X to the 5 times 3 is 15, power rule, and then y to the first, 1 times 3 is y to the third, end parenthesis. Over here, we still have what's in parentheses, but let me remind you, if you have a negative out in front here, what number is really in front? That would be a -1. I'm going to go ahead and write it in because on the next step, I'm going to need to remember that there's actually a -1 there, all over 3x to the negative first power. All right, now we're ready. We've done with the exponents. We've applied all the power rules that we needed to. Now we're ready to multiply the top. And so on top, we multiply the numbers. That's going to be -27. So 27 times -1. I'm going to combine my x's, like bases, add the exponents. So we end up with 17 x's on the top. And they'll combine the y's. Remember, there's really a 1 here. Y to the third, and add the exponent of 1. We end up with 1 more y. So that is y to the 4th. And then all over 3x to the negative first power. All right, we're getting there, but we're not quite finished yet because we now have to divide, right? We multiplied on the top. Last step is to do division. So we've got the numbers to deal with first. And so if you think about -27 over 3, that's going to be -9. 27 has more than 3, so -9 is going to end up on the top. We now have these x's to deal with to simplify. And you could think about it either way. You could think about it as flipping this 1x up to the top and combining it with the 17. So if I have 17 up here already and I flip this one to the top, I'm going to have 18. Or you can think about, as a subtraction problem, 17 minus -1. Right? We're subtracting, we're dividing here, so we're subtracting the number. 17 take away -1 is the same thing as +1. And so that would be 18. So x to the 18th, oh, that's a 10, 18th. And then we also end up with y to the 4th. Now let me say that again about that, where this 18 comes from. Think about taking this negative exponent and just flipping it upstairs. But you've already got 17 x's, and so we're adding 1 more to it. That's where this 18 comes from. So your final answer is -9, x to the 18th, y to the 4th, and if you can do that example, you can probably do them all. One last thing before you turn the video off, and that is, I know I said 8 examples, but this is a bonus example. One thing that you might run into, and we've talked about this before, is what if you see a big old mess of stuff, all in parentheses, raised to the 0 power? Oh, let me put an x here. So 16x, and then in parentheses, 4x to the 4th, y to the -5th. Now, you might be tempted to, go ahead and try to multiply this stuff and combine it. But remember, anything to the 0 power, that's this whole part right here, is going to be 1. And then it's going to be times 16x. And so your final answer here would just be what is not being raised to the 0 power. That is 16x. So just keep that in mind. If you see a bunch of stuff raised to the 0 power, the final answer might not be 1, but part of this is going to be 1. So that's your bonus example. Good luck practicing on combination of laws of exponents.